Good morning, students. Today we are doing with isothermal process and adiabatic process. Isothermal process means it is a process in which the temperature of the system remains constant. Isothermal process is a process in which the temperature of the system remains constant. So, iso means same and thermal means temperature. So, isothermal, same temperature. So, temperature remains same, while all the other variables will change. So, for an ideal gas, we can say like this: PV is equal to nRT, where n is the number of moles, which is a constant, R is universal gas constant, and T is also constant because for isothermal process. Therefore, you think like this: n is constant, R is constant, T is constant. So, can I say PV is equal to constant? Yes, PV is equal to constant. So, for an isothermal process, PV is equal to constant, or I can write P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2, or I will write P proportional to V. That means pressure is inversely proportional to volume for an isothermal process. So, if I draw the graph between pressure and volume, when volume increases, pressure decreases, and vice versa. That is why the graph is a curved line like this. This curve is known as isothermal curve. Okay, this curve is known as isothermal curve. So, remember, for an isothermal process, temperature remains constant. Therefore, I can write PV is equal to constant from the ideal gas equation. Then P1 V1 is equal to P2 V2. That means when pressure increases, volume will decrease. When pressure decreases, the volume will increase. Okay. Now, what are the essential conditions for the isothermal process to happen? The first condition is the system and the surrounding should be separated by a diathermic wall, so that there is exchange of heat between the system and the surroundings. Only then the temperature of the system can be remain constant. For example, when the gas is compressed, its temperature will increase. So, in order to keep the temperature constant, some heat has to be given from the system to the surroundings. System means there is a cylinder filled with gas and a piston. So, heat has to be given out to the surroundings. Now, if I am pushing the piston upwards, then the gas will expand. When the gas expands, it cools down. Okay, when the gas expands, it cools down. So, in order to maintain the temperature constant, some heat has to be absorbed from the surroundings. Only then the heat will remain constant. Otherwise, the gas will cool down. So, the heat exchange has to be taken place between system and the surroundings. That is why it should be separated by an diathermic wall. So, that is the first condition. Second condition, the process should take place slowly, so that it should get time to exchange heat with the surroundings. So, write the question: what are the essential conditions for an isothermal process to take place? The first condition, the walls of the container must be perfectly conducting to allow free exchange of heat between the system and the surroundings. Number 2, the process of compression or expansion should take place very slow so as to provide sufficient time for the exchange of heat. Now, isothermal expansion of an ideal gas. When an ideal gas expands isothermally, the work done for expansion is given by the equation W is equal to RT log V2 by V1. You don't have to study the derivation for that. Just study the equation. Work done for an isothermal expansion of an ideal gas is W is equal to RT log V2 minus V2 divided by V1. Now, how can I apply first law of thermodynamics to an isothermal process? How can I apply first law of thermodynamics to an isothermal process? Delta Q is equal to delta U plus delta W. For an isothermal process, temperature remains constant, which means internal energy is constant. So, change in internal energy will be 0. Delta U is equal to 0. So, I can write delta Q is equal to delta W. That means, for an isothermal expansion, work done, the heat supplied is only used for doing the work for expansion. Okay, there is no rise in the temperature. So, heat supplied is equal to the amount of work done by the gas on the surroundings. Now comes to the next process, which is adiabatic process. Adiabatic process means it is an insulating process. There should not be any exchange of heat between the system and the surroundings, like a tea kept in a thermoflask. So, in adiabatic process, everything can anything can happen, like there can be change in pressure, change in volume, which will give rise to change in temperature also, because here it is an insulating process. So, there is no exchange of heat between the system and the surroundings. Therefore, when the gas is expanded adiabatically, it will cool down, because it cannot, as I explained just before, it cannot absorb heat from the surroundings, because it is an insulating wall. So, in adiabatic process, it is an insulated process. So, no exchange of heat is there between the system and the surroundings. So, when the gas expands adiabatically, it cools down, and when the gas is compressed adiabatically, it gets heated up. Okay. So, the process is sudden, and the next thing is the process should take place very fast, and the walls of the container should be adiabatic. Those are the two conditions. So, you can just write a question, what are the necessary conditions for the adiabatic process to take place? What are the necessary conditions for the adiabatic process to take place? First one, the walls of the container must be perfectly insulating, so that there cannot be any exchange of heat between the system and the surroundings. Number 2, the process of compression or expansion should be sudden, so that heat does not get time to be exchanged with the surroundings. Okay, so those are the two conditions. I can give you an example regarding that. See, when you inflate the balloon to maximum, and imagine you are playing with the balloon, and you just take the balloon closer to your face and prick it with a pin. So, the balloon bursts and the air will just come to your face. will that be cool air or hot air? You can try. Just keep the balloon somewhere this much distance and then do it. So when the air comes from the balloon, that air will be cool air. Even though we are keeping the balloon in the sun, the air inside the balloon will be hot, but when the balloon is bursting, the gas is expanding very fast. Sudden expansion is adiabatic. So sudden expansion of the gas causes cooling. Sudden compression of the gas causes heating. Now the second example, cycle tire of the cycle tire suddenly burst, the air will be cooler. Now mountain tops are cooler because as the gas goes up, the gas will expand adiabatically. So when the gas expands adiabatically, it cools down. That is why the mountain tops are cooler. In Ooty, Munnar, Kodaikanal, everywhere, when you go to high altitude, it is cooler because of this reason. The gas expands adiabatically. The adiabatic expansion of the water vapor causes condensation and the rain to fall. So all those are the examples for adiabatic expansion. Okay. Now see, usually in the isothermal expansion, I just wrote PV is equal to constant and P proportional to 1 by V, that is called Boyle's law. P proportional to 1 by V is called Boyle's law, or PV is equal to constant. If we write Boyle's law in adiabatic process, we have to write PV raised to gamma equal to constant. This letter is gamma, PV raised to gamma equal to constant. You can write Boyle's law only like this. So P1 V1 raised to gamma equal to P2 V2 raised to gamma, where gamma is the ratio of specific heats, Cp by Cv. And this we have studied for monoatomic gas, diatomic gas, triatomic gas. What is the value of gamma? That we have studied in the previous video. So P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Now what is the work done for the expansion of an adiabatic process? Work done to expand the gas adiabatically. W is equal to R by gamma minus 1 into T1 minus T2. So you have to write like this: W is equal to R by gamma minus 1 into T2 minus T1 or T1 minus T2, like this. You can write either T1 minus T2 or T2 minus T1. Okay. So that's all about adiabatic process. Thank you.